Hey folks, you're listening to the Java Easily podcast, episode number 6. Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer. Hey everybody, welcome back to the podcast. Now as usual, just before we start, we'll give a quick shout out to the Java Beginner Starter Kit. So if you haven't downloaded this yet and you're completely new to Java, then go over to our website, that's javaeasily.com, and go grab the Java Beginner Starter Kit from there. It's a nice beginner-friendly guide designed to get you up and running with Java as quickly as possible, and it's completely free and should get you up and running with Java programming in no time at all. Now that's out of the way, in this episode we're going to have a look at the background to object-oriented engineering, find out what the motivation is behind it, where it comes from, and get a handle on some base terminology. So let's get to it. So, what is an object-oriented system? So an object-oriented system is basically a system that is composed of objects. Now these objects, they interact with each other by communicating with each other, or by one object requesting another object to do something, and then maybe having something returned back to it, that kind of thing. But ultimately, you have a system which is composed not of individual procedures or kind of subroutines or functions which you have in systems which are programmed before object-oriented engineering came out. Instead of that, you have a system composed of these objects. So at this point, you have in your head the notion of, okay, there's some kind of system, there are these quote-unquote objects which are floating around, and they're somehow talking to each other to get something done, to get their requirements done, whatever that system might be. So whether you're designing, for example, a game to play chess, a computer game like a platform shoot 'em up, or an e-commerce website, whatever it might be, ultimately, in an object-oriented system, you design that system out of these so-called objects. Okay, so that's all well and good. The next question is, of course, well, what is an object? Well, in order to answer that, it's instructive to have a look at what you had to do when you were programming systems before object-oriented engineering came out. So before then, you just had procedural languages, and those are basically where you have the basic constructs that you're probably already familiar with as a beginner Java developer. So things like for loops, while loops, conditionals, those are your if, else, else if, those kind of things, or switch statements. You have the notion of variables, of course, where you can actually store data inside, and you have the notion of methods or procedures which encapsulate a set of statements together. Now, in a program that's programmed procedurally with a procedural programming language, like for example BASIC or C, Pascal, Fortran, other much more older languages which are way back in the history of computing, the program is programmed in a way whereby you have methods which call other methods. So this is sometimes known as stepwise decomposition. So the idea is that you have a problem that you want to solve. So for example, let's consider if you're writing a computer program to make a cup of tea. If you're doing that, then you need to break it down into the individual procedures or methods, if you like, each individual step, which comprises a specific kind of subtask of the program that you're programming. So in the case that you want to make a cup of tea, maybe the first thing you do is boil a kettle of water. Maybe the second thing you do is get a teacup, put a tea bag in it. Maybe the third thing you do is pour the water onto the tea bag in the teacup, that kind of thing. So those would be your top level methods in this program which would make a cup of tea. And the first method there, which is boil a kettle of water, that as a method in and of itself could again further be broken down into other steps, into sub-steps if you like. So in order to boil a kettle of water, you first of all need to take the kettle, then you need to open the tap, open the faucet, so the water starts flowing out. Then you need to basically put the kettle under the water to collect the water, that kind of thing. The whole example is very contrived, but you get where I'm going with it basically. The idea is that you start off with some high-level task or some problem that you need to have solved. You first of all break that down into its steps, individual steps, the high-level methods, which can be done sequentially to achieve what you want to achieve. And then for each one of those methods, you further break it down into other methods or procedures, and you continue doing that in such a way that the smallest method that's written is something that's achievable and implementable using the lowest level constructs that you have. So using those for loops, while loops, conditionals, variables, and that kind of thing. So effectively you have a problem, you break it down into a set of high-level methods, you break each method down into further methods, and keep doing that until you've got a nice procedural implementation of the problem that you're solving. And the idea is that each method will be kind of self-explanatory in terms of what it does, in terms of its name, and any parameters that it would take, so any arguments that it would take in. Now, when you're programming in this procedural kind of way, your basic unit of coding in that respect is pretty much the method or the procedure. A method is the same as a procedure, by the way. It's just that they're different names pretty much for the same thing. So you have method, you have procedure, subroutine. You can also have function as well. Although function normally implies that you're actually returning a value in addition to possibly taking some values. But ultimately, at the end of the day, your thought process is to decompose the solution to your problem in terms of writing and calling methods, which, when they work together, ultimately get the job done. Now, a problem with this approach to software engineering is that it's good for simple things and for writing software that doesn't change much. However, where it falls down is when you have much larger systems where you have possibly overlapping pieces of functionality, and then you end up with all sorts of bad things that start to happen. You end up with duplicated code. You end up with global variables, which basically means a variable that can be modified by any of these methods or functions. And that might not seem that bad. It might seem pretty innocuous. But when you imagine you've got a huge system, maybe with thousands of these different methods, and you have this poor tiny variable which happens to be global, it happens to be public, it can be accessible by any of these thousands of methods, then it can often be very difficult to pinpoint which method has changed a variable, why it changed a variable. Maybe several methods changed a variable along a particular code path, doing one thing, whereas along another code path, maybe it was only changed twice, all these different things. And also, don't forget as well, in a large system, for example, you're not just going to have one variable. You might have, say, for example, 100, 200, 500, 1,000 variables. You don't know. So imagine you're designing a program like Photoshop, for example, for image manipulation. If you imagine you were designing that program and you designed it in a procedural way, then you can imagine all of the tens of thousands of methods you'd have which could manipulate images. Imagine all of the hundreds of variables you'd have for even just the state of the UI, for example, whether you're enabling and disabling buttons, showing menu panels, that kind of thing. You could imagine that it's going to be pretty much, after a certain time, it's going to be like quicksand programming, and it's just going to pull you down, suck you down, and it's going to be very, very difficult to evolve the software, to be able to make changes, also be very difficult to find bugs and to track down where defects happen, that kind of thing. So yeah, most of the time when we're looking at procedural programming and when it's discussed, for example, in university lectures, they really just talk about very small programs, but you really have to think, kind of project out, in fact, with all these design principles that you ever come across, project out how that would look in a large-scale system to be able to truly appreciate the deficiencies of one programming style and the advantages of a different one. So anyway, that's procedural programming. So up until C++, actually Smalltalk I think it was. I think it was Smalltalk first, then C++, and then Java came out. I'm not too sure of the exact time frame, but those were the primary object-oriented languages that came out. But anyway, object-oriented engineering came out, object-oriented systems design, and what that was, that basically decided, it said, you know what, it's difficult to just have a ton of global variables in a system and to have a ton of methods in a system. It's not a scalable approach to developing software, mainly because we can't contain, rationalize about, and control how the data is changing in the program. It's just too much of a headache. So what we'll do instead is we'll basically put methods and the data which those methods operate on, we'll somehow put them into a structure which is related. And this structure is known as the object. And this is the notion of encapsulation, where you basically have an object which has a state, and then you have methods inside that object which can operate on that state. And the idea of this encapsulation, is that it encapsulates, which means it seals off from the outside world, any external access to the data of the object, which is really, really good, because what it means is that if that object changes its state, because, for example, supposing there's some defect or some bug, then we now don't have to go trawling through tens of thousands of methods and trying to work out in which sequence those methods were called, which is like trying to find a needle in a haystack. Instead, we can just rationalize about the code paths, in other words, the methods which can be called on that specific object and that object alone, to work out where the issue is. And the reason is, of course, is because those methods which are exposed on the object, those methods which are part of the object, are the only things that can change the state of the object. This is this big idea of encapsulation there. So encapsulation, you're putting the methods which operate on a specific set of data right next to the data on which they operate, and you're bundling that into a structure, and this structure is called an object. Now at this point then, we go from this kind of stepwise decomposition, which was this notion of having one thing we need to do, splitting it up into multiple steps or methods, and then further dividing those steps or methods into other methods, and so on until we got something which was sensible and achievable and implementable. The mindset shifts from doing that with this so-called divide and conquer approach. It goes from that kind of divide and conquer or stepwise decomposition, whatever you want to call it. It goes from that approach of problem solving to a completely different paradigm, which is basically how can we construct objects which have methods and state. How can we write a system which is purely based on objects? And those objects are going to interact with each other. In other words, they're going to invoke methods on each other or send messages out across the system, whatever it might be. But somehow then we're going to assemble a system based on these objects. So now we're no longer thinking in terms of how can we take a method, decompose it into other methods, decompose it further still into other methods, and overall that kind of like tree of methods, that set of methods, will kind of roll up to the top and then get the job done. Instead, we're going from the idea and thinking, okay, what objects do we need to create? What methods do we need on those objects? What data do those objects need to hold? And how are those objects going to communicate to be able to design our system? So that's the whole idea of object-oriented engineering at its most base level. Now, if you're completely new to Java and you haven't really started yet, you might want to take a course which we've got going currently, which is over at courses.javaeasily.com. That's courses.javaeasily.com. It'll get you set up with the tools you need to be able to start coding in Java and give you what it's like to program as you look over the shoulder as I just take you through some code which I'm programming there for you in that course. It's a good first resource to start off with. Also, if you haven't joined the Facebook group, that's also a great place to join as well. You can look it up on Facebook. It's called Learn Java Easily, Java Programming Mastermind Group, and it's designed to be a nice friendly place where you can come and join, hang out and get answers to your Java questions that you've got as well. So that's about it for today. All that remains to say is have a great day, stay safe, and we'll speak soon. Bye.